Let's share some of the videos regarding the topics correlation and regression. Did you go through them? So those are in the chapter number 6 of the first PUC book which I have downloaded. So you can go through the topics there and also look into the videos what I have shared, and you can look into some work examples also in the textbook. If you have any doubts, you can ask me or ping me anytime. So if you want a session or a class regarding those things, I could take up a Zoom session. So we'll now look into a new topic which could be called as the foundation for the subject statistics, what is called as probability. Probability, to simply put in the simple sense, it is the chance. So it is the measure related to chance. So a numerical measure which measures the chance of occurrence of an event. Now usually we talk about probabilities in the cases where there is uncertainty about happening of some of the cases, because if you know that certainly something is going to happen, then you are 100% sure. If there is uncertainty, in those cases we talk about probability. And when we say uncertainty is there, that means you cannot exactly guess what is going to happen. So there are multiple cases, or statistically we call them as results or outcomes or outputs possible. Therefore, there is what called as uncertainty. Now, how this concept probability came into existence in the early 16th and 17th centuries? People, used to go to the casinos or the place where they used to bet some amount and do some gambling. They always, as a human, they want to maximize their returns, or say whatever the price or the amount they get. So in order to maximize it, so they wanted to know what is going to happen with the result of this. That is in advance. So if I play this particular game, if I opt this particular rule, what called as strategy, then what is going to happen to my outcome or my gain. So optimization of gain or the outcome or the gain based on the possible outcomes. So one thing is very much certain here. You can talk about the cases only if you, chance or the probability, only if you know all possible cases of the outcome. So this all possible cases could be finite or experiment. So this is what we are looking into. Now we'll try to put these things in the mathematical and statistical form. So what we have, something is going to happen, but you are not sure what exactly is going to happen, but you know all such possibilities. All such possibilities could be countable, it could be, infinite. And then you can talk about what exactly a particular case will happen. And if you quantify that in terms of a number, that number or measure is called as chance of occurrence of an event, which is probability. Okay, so the topics what I will be discussing today are under chapter 9 and 10 of the first PUC book, and also chapter 5 of the second PUC book. You can go through and make your notes from those books, those topics. So all this starts with the term called as experiment. The experiment is simply to be called as a set of actions which produces some reactions, or I could say outputs, or the statistical term what called as outcome. Now these outcome is what is our interest. So I want to know what exactly the outcome is. Now this set of actions of this experiment could be anything. Like say you're tossing a coin, you want to know will it result in a heads. So you're throwing the die, you are observing the sky, the amount of clouds, and you want to guess whether it is going to rain or not. Then you are looking into a flight, you're boarding a flight. Now you are worried whether the flight will take off and land successfully, or there will be a failure landing or a troubled landing. So these are all the experiments, and these are all some outcomes of your interest. So if you know what exactly the possible outcome you're talking about, and then there are basically two methods of assigning what called as probabilities. Now here in all these examples, there is uncertainty. You are not very much sure whether it will rain or not, whether I'll get a head or tail. So will it be a successful flight or a failed flight? So there are various cases of the results. Therefore, there is uncertainty involved in the outcome. So whenever there is uncertainty involved in the outcome, such experiments are called as random experiments. Why they are called as random experiment? Because the outcomes are different and are random, because you cannot predict them. If you can exactly predict them, then they are not random, because you know what exactly is going to happen. In those cases where outcome is certain and known, those experiments are called as deterministic experiments, because even before conduction of the experiment, you can actually say what exactly the outcome is or the output is. So those are called as deterministic experiments. Say if you add 2 to 3, definitely you will end up getting 5. So you need not have to sit and use a calculator to produce the result. Even if you use various other cases, you will end up getting the same number. So whoever does this under the same conditions, you will get back the same result. Whereas if you look into the experiment of tossing a coin, so I toss the coin, I may get the result as heads. So in the second time I toss the coin, I may get the result as heads. Third time, I may get a tail. So every time I conduct the experiment, I cannot guess what exactly will be the outcome. So to know what is the result, here you have to actually conduct the experiment. Only then you can see the result. Here, without even considering or conduction of the experiments, you can actually have a guess on what possible outcomes are. So you know the outcomes in advance. Just to verify the result, you will be doing the experiments. So the experiments which you conduct in the laboratory of physics, chemistry. So you know that if you add chemical X with chemical Y, that will certainly produce chemical Z. So this is already known, and theory have been established. But as a student or as a researcher, I want to see how exactly it is happening, what are the other things involved around it. So just to verify the result, we will be conducting the experiment. So such experiments are called as deterministic experiments, and these are called as random experiments or statistical experiments. Now we have noted that the statistical experiments have several possible outcomes, and if you can write all those possible outcomes in the form of a set, then that set is called as sample space. Okay, so the first method of computing the probabilities is by what called as mathematical or classical approach. Mathematical or classical approach, where you will look into what is called as the sample space as the first step. So you know the experiment, you know all possible outcomes of the experiment, you are listing all possible experiments in the form of a set. Then that set of all possible outcomes of random experiment is called as sample space, and the sample space is indicated by the symbol, the letter S. Now, based on the type of the experiment, you can have different possible types of the sample space. again which are broadly categorized into finite sample space and infinite sample space. Now we hardly use the infinite sample space because in most of the cases of infinite sample space, computation of probability using this approach becomes very much difficult. In those cases, we use another approach called a statistical or the empirical approach. Okay. So once you know the sample space, then you will look into what called as events. Now mathematically I can define event as a finite subset of sample space, finite subset of sample space. Finite subset of sample space, but here you will look into the outcomes of your interest, or which we call as the favorable outcome. So as said, we are going to have a guess, or what is the chance that something is going to happen. So that something is what is of your interest, and that you have to quantify in terms of simple notations, and again write that in the form of a set, and that is called as an event. So events are indicated by any other letter other than S. You can have A, B, C, D, etc. If you have multiple set of events, you can use A1, A2, E1, E2, etc. And so many number of events can be defined. So let us take an example to understand this. So if I'm looking into the experiment of tossing a coin. Now this coin tossing experiment is very often conducted in the real life situation to judge the scenario, like say who will start the particular game or who will win the particular lottery, so many such cases. So when I talk about tossing a single coin once, then the possible outcomes are H and T. So if I toss a single coin once, the possible outcomes are just H and T, where H indicates the outcome heads, T indicates the outcome tails. So this is the sample space. Now I am interested in just observing heads. So I'm tossing the coin. I'm interested in only getting heads. So only heads is my favorable outcome. So this is how you define the events. Now I can say E2 getting no heads at all. Then that means I'm interested in getting T. I can define E3 getting a tail. Again, that is T. So E2 and E3 are same, but the definition of event are different. So I can define n number of events on a single sample space. So I can have an event which takes all the possible outcomes, same as that of your sample space also. So you could have a case where S is equal to E4. So certain type of events could be specified. An event which contains all the elements as that of sample space is called as a sure event, because it is very likely to happen every time when you conduct the experiment. So this is your sample space, this is your event. Now we see what called as happening of an event. Okay, so you are interested in a particular outcome. So if you conduct the experiment and the experiment actually results in a particular outcome which is present in the event, then we say the event has happened. So if the outcome of experiment is in event E, then we say E has happened. Then we say E has happened. Say for example, I'll toss the coin. So I'll get the result as heads. So coin has resulted, the toss of the coin has resulted in heads. Then I can say E1 has happened because my E1 event is getting heads. And then here there is no head, here there is head. So I can say E4 has also happened. So this happening could be verified only after conducting the experiment. Okay. So happening of an event. Next is the terminologies the mathematical part of the theory. So we have S, we have E. So I have some elements in S, some elements in E. So we indicate the number of elements in a set by the symbol n of s. You are very much familiar this in your, you have gone through these cases in your high school also. N of E, n of s indicates the number of elements. That is, just count how many elements you have in the sample space. N of s is generally indicated by n, n of E is indicated by m. And if I know these things, then probability of event E is defined as the ratio m is to n. So m divided by n, or simply you can say number of elements in E divided by number of elements in S. So this is how we define the probability, and this is read as probability of event E. Probability of event E. It is very easy to compute probability, but only thing is that you should know what is S. So the requirement is finite sample space and finite event. So if you're talking about infinite cases, n becomes infinite. Any finite number by infinite produces always zero. So this method doesn't produce the probability whenever you are talking about the case where your S is very large or infinite, E is very large or infinite. So this is called as the mathematical definition of probability. Now looking into the requirements or the condition. First condition is that you should have finite sample space and finite event. Second condition is that whatever the outcomes you observe, we assume outcomes are equally likely. And this is an important assumption. Okay. What is this equally likely? Equally and likely. So if you have several possible outcomes, then occurrence of one is same as occurrence of other. That is, the chance of occurrence of one is same as chance of occurrence of other. Okay. So to understand this, what this says that if you take, say, a coin and toss it 10 times, then we say you should observe 5 heads and 5 tails. So if this happens, then we say occurrence of head and occurrence of tail are equally likely. That is, whenever we conduct the experiment for a certain number of times, we will observe the different outcomes the same number of times. But in real situation, this is not definitely not going to happen. You can just try it out. So take 10 coin, a coin and toss it 10 times. See, you might end up getting only 3 heads, 7 tails, or 2 heads, 8 tails. Or if you are unlucky, you might get all possible heads, but very rarely you observe 5 heads and 5 tails. I'm not telling that you will not at all observe, but it is a very rare situation, but that assumption is taken. Now, if you are it could be generalized. So if you're talking about, say, tossing a coin 100 times, then equally likely assumption means out of 100, some cases, 50 cases will be heads, the remaining 50 cases will be tails, or most likely very much closer also. Okay, so this could be an assumption where in most of the cases it is satisfied, in some of the cases it is not satisfied. So this definition could be applied only under this case, equally likely case, equally likely outcomes, and the sample space is finite. So this is the probability. So we'll take some problems and see how to obtain the probabilities. I'll just take the simple problems, one or two, and I'll also tell you and look into some of the complicated problems also which are in the textbook. So if I have the sample space of, say, tossing a coin, then I have s is equal to h comma t. So I have E1 as getting heads. So the favorable outcome for E1 is just h, and E2 is getting head or tail. So it is h comma t. So you have n of s is equal to 2, n of E1 is equal to 1, n of E2 is equal to 2. One element inside the set, two elements inside the set. Therefore, according to mathematical definition, probability of E1 is n of E1 by n of S, which is equal to 1 by 2 or 0.5, which indicates that there is 50% chance of observing heads when you conduct the experiment. And if you look into the second case, that is 1, which indicates 100%. So we rarely convert the result into percentage, but always talk, try to understand this, what is happening, what is probability actually telling you. So if you look into P of E2, it is half. So generally we say there is 50-50 chance of observing head or tail in the coin. Why we say 50-50% chance? This is the reason, because you have assumed that the events are equally likely, therefore it is 50% chance. And such coins are called as unbiased coins. So the coin which produces, equal number of heads and equal number of tails, whenever a set of experiments or trials are taken, then that coin is said to be unbiased coin. Now, there are cases where you will have the number of heads, not same as the number of tails. In those cases, we say the coin is biased. Biased coin doesn't produce equal number of heads and tails when you take the so many trials. Say for example, if you take 10 trials and your trial results in say 3 heads and 7 tails, or almost 10 tails only, whatever could be the case, unless it is same, you can say that the coin is a biased coin. So this also tells you how to check whether the coin is a biased coin or unbiased coin. So take a coin, toss it for a large number of times, say 100 times, and if you very much closely observe that your heads and tails are very much closer to each other, like 50-50 or 48-52, even 40-50 or 40-60 in some cases, you can say they are almost same. So in those cases, you can say the coin is biased. But in the cases where you are observing, say, very less number of heads and tails, like say 18 heads, 82 tails, and so on, then definitely the coin is producing one particular outcome many times compared to the other. Therefore, the coin is said to be a biased coin. So this is how we compute the probability. So we know that to compute the probabilities using this, you are just interested in how many elements are there within the set, that is the event and the sample space. So without knowing the sample space and the events, you cannot generate the probabilities. Now for you, in the examination, the problems will be on, say, the throw of 2 coins, 3 coins, 4 coins, and various events could be asked, and you have to write the sample space in all those cases. And then we'll talk about the throw of a single die as well as say 2 dice. 2 dice again, as the outcomes, so we'll end there. And various number of events will be given. You have to write those events, count how many numbers are there, and use the formula P of E is equal to N of E by N of S. Now let us understand the concept of 2 and 3 coins, and 4 coin will be a homework. So if I toss first coin will result in head and a tail. Now one thing is very much sure here, whether you toss the coin 2 times or a single coin twice, the result is one and the same. So we are talking about the experiment of toss of a coin twice. So one coin na ಎರಡು ಸಲ ಟಾಸ್ ಮಾಡೋದೇ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, ಅಥವಾ ಎರಡು ಕಾಯಿನ್ ನ ಒಂದು ಸಲ ಟಾಸ್ ಮಾಡೋದು, 2 coins tossed once. Both are same because both produces the same outcome. How it produces the same outcome, we'll see. So I have tossed 1 coin and immediately I'll toss the other coin or together, or if I just have 1 coin, first observe what is the outcome, then toss the second coin. So now if I bring the second coin here, if I already have observed the head as a case in the first coin, then again coin 2 will produce head or tail. So again coin 2 will produce head or tail. So totally in your sample space, now you have 4 possibilities. which are HH, HP, TH, TP. So imagine that you're tossing two coins and see what happens to the result. So we are interested in the result of the experiment here. So result of experiment. Experiment is taking two coins. So you have coin 1, you have coin 2. Coin 1 may produce H. Coin 2 may also produce H. So this is one outcome because experiment ಇರೋದೇ ಇಲ್ಲಿ ಒಂದು ಕಾಯಿನ್ ನ ಎರಡು ಸಲ ಅಥವಾ ಎರಡು ಕಾಯಿನ್ ನ ಒಂದು ಸಲ ಟಾಸ್ ಮಾಡೋದ್ರಿಂದ this is not result 1 result 2 together they are one result. Now what are the other possibilities? As that sample space indicates the set of all possible outcomes, so you have to look into all possible such cases. So what are those cases? You can have head in the first coin, head in the second coin, or head in the first coin, tail in the second coin, tail in the first coin, or head in the second coin, tail in the first coin, and tail in the second coin. So you have four different possible outcomes for the experiment of tossing the coin twice or tossing two coins once. If I include the third coin now, the third coin will have again head and tail. So if you look into all the three cases now, so three individual outcomes of three different coins or three tosses becomes one outcome of the particular experiment. Now the experiment is tossing the coin thrice or tossing three coins together once. So what happens if I toss three coins once? So if I toss three coins once, then I could have my outcomes as a situation where coin 1, coin 2, coin 3 all are heads. Coin 1, coin 2 head, coin 3 tail. So two outcome, head, tail, head, head, tail, tail. So we have four possible outcomes with first coin taking heads and four outcomes with the first coin taking tails. So 4 plus 4 produces 8 possible outcomes. I'm telling possible. I'm not telling all or these will be the outcomes because when I conduct the experiment, one out of this is possible. One out of this is possible. Now the question is, which is possible? Now often, when you go into fun fairs or when you meet with your friends and if you're involving in the games like this where some betting is happening, so if you know that what are the outcomes of those possible games and if you could list out those possible outcomes, and then you can see whether to bet the money on a particular event or not. Now let me say my event is, I'll take E1 for the case of two coin experiment. E1 is getting both heads or both heads. So let me take it a simple one. So getting both heads. So me and my friend will meet. So I'll say, let's just play some game to make some money. So we'll each toss a coin. If the outcome is both head, I will get say 10 rupees from him. If the outcomes are not heads, I have to pay him 10 rupees. Okay. So if this is the situation, so let me say what happens to my probability. So I should know, will I actually get two heads when I toss or do this particular game or play this particular game. So P of E1. So when I say getting both heads, only one favorable outcome out of 4 in this case, which is HH. Therefore P of E1 becomes N of E1, which is equal to 1, which is M, and N of S, which is equal to N is equal to 4. So this is M divided by N, which is 1 by 4, which is 0.25. So which is telling that the chance of winning or chance of getting 10 rupees is only 25%. So what does it mean? It means that if you play this game 4 times, you may end up getting only once 10 rupees. You will lose 10 rupees thrice because his winning probability is 75%. What is his winning probability? His probability is not even, because he will get the money from me if that event even doesn't happen. So not happening of even is indicated as even bar or even dash, and that is called as complement of the event even. So that is also an event. So that is, mathematically 1 minus P of E. So that will be 1 minus 0.25, which is 0.75 or 75% case. So what is this telling is that whenever you toss two coins, there is less chance that you will observe both the heads. On the other hand, if I change the rule, I will get 10 rupees if the result is same. If the result is same. So when I mean result is same, I mean I should get both heads or both tails. So in that case, my favorable outcome. So I will be interested in getting H comma H or T comma TS outcome. So there are two favorable outcomes. Now the probability becomes 0.5. So there is 50% chance of winning. So instead of playing the game with the event E1, now if I have taken that as E2, I can play the game with E2. So there is 50% chance. So for both of us, therefore, I may show some interest in generating or playing this particular game, because the chance of making money for both of us are same. So now it is purely based on the luck, whether I will take 10 rupees or he will take 10 rupees. In the earlier case, it was not based on the luck, but it was based on the chance. So this is how you compute the probabilities. And some of the cases where you look into these possible outcomes, now various events E1, E2, E3 will be given to you. You have to identify what are the favorable outcomes for this from the sample space, and you have to compute the probabilities. Okay. The next experiment is based on the throw of a dice. So if I throw a dice once, a single dice once, then if I say what are the results, so here we are talking about the regular die, that is the 6-faced dice. There are various types of dice, 4-faced dice, triangular dice, hexagonal dice, and so on. So here we are talking about the cube on the 6-sided geometrical figure. So we have S is equal to 1 to 6 as the possibilities. Now I can end up giving or defining so many possible events. So I could say even what is the chance of observing even number or odd number or number less than 4, number greater than or basically less than or equal to 2, or observing only multiple of 3. So many such cases could be defined, many such events could be defined, and for all those cases, you can obtain the probabilities. So even numbered, so the events which are favorable for this or the outcomes favorable for this event is 2, 4, 6. In case of odd number, it is 1, 2, 3. So you can say that these two events are complementary to each other. What is complementary? Complementary event of an event is an event which talks about not happening of an event number. Now, since I have 1 to 6, a mixture of odd and even numbers, if I say my event even is even number, then not happening of that is definitely odd number. So E1 and E2 are complement to each other. So you can say E1 is equal to E2 bar, or E2 is equal to E1 bar or E1 dash. So what is the chance of observing an even number? So 3 cases out of 6. Therefore, probability of E1 is equal to 3 by 6. Probability of E2 is also 3 by 6. Observing a number less than 4. So the numbers which are less than 4 are 1, 2, 3. So again the chance is 50% there. Observing a number less than or equal to 2 is 1, 2. Therefore, n of E4 is equal to 2. Therefore, the chance is 2 by 6. Now, multiple of 3, I have only two numbers. 3 ones are 3 and 3 twos are 6. So, 3 and 6 are the multiples of 3. So, I have n of E5 is equal to 2. Therefore, probability of E5 is also 2 by 6. So, this is how we generate the probabilities. Now, whenever we have a case where we are talking about the conduction of the experiment where the repetition is involved, where the single trial with a single experimental tool like a coin or that, if it has say A outcomes and if you are repeating it B times, then n of s will be always equal to a power t. So this is, we have already understood this. Say for example, I'm talking about coin 1, then I have two outcomes. So if I toss single trial, so one toss leads to two outcomes. If you're talking about, so repeating the task, so let me say I'm repeating it two times. So repeating two times means two toss of a coin or two coins are tossed once. So we have b is equal to 2. So we have n of s is equal to a power b, which is equal to 2 power 2, which is 4. And we observe those four outcomes are HH, HT, TH, TP. Now, if I increase this b to 3, we also saw that repeating three times, which is three toss of a coin or three coins are tossed. So we have b is equal to 3. So n of s will be 2 power 3, which is 8. And we looked into those possible 8 cases. So we are using some mathematical formula to observe how many elements are there in the sample space, because ultimately our probabilities are based on how many are there. And just to write the event, we need what are those favorable outcomes. But even without writing the sample space also, we can look into that. So there are certain mathematical formulas like this, which are available to look into the total possible outcomes. Now, sometimes we are, interested in, some other experiments, like say selection, sampling, and those such cases. When we talk about what called as combination. So when you're talking about selection, immediate concepts of mathematical concepts are combinations and permutations. So whenever you're dealing with the probabilities which involve selection of some items, like say there are 20 boys, I have to select two girls, and say 20 boys and 30 girls, I have to select two boys and five girls. Then those two boys could be any of the pairs, two pairs of those 20 boys, 20 say two possible pairs. And then again, in terms of girls, I can have various groups of 5 out of 30. So selection of one involves the problem mathematical concept, combination and permutation. Now, similarly, expanding this result into the throw of a dice. So, a single toss or a throw of a dice has 6 outcomes. So, we have 6 outcomes. Now, if I repeat this 2 times, that is, my experiment is throw of 2 dice together, or which is same as